Assalamu alaikum. Now we will start the part 2 of our unit of course information security. As we have discussed already that we will study communication security and countermeasure in this unit. Now then in the second part we will start with the switching technologies used for communication for securing the data transmission process. Two system individual computers or LAN local area networks are connected via multiple intermediate networks. The task of transmitting data packets from one system or from one network to another is a very complex process. To simplify this task, switching technologies were developed and introduced. The first switching technology is called circuit switching technology. As shown in the figure, the circuit switching technologies, one system and the one side of local area network or the wide area network is communicating with the other system on the other side. Dedicated physical pathway is created by the system between the two communication parties. Call is established. The link between two parties remain same throughout the conservation. Fixed and known transmission time is dedicated for that. Uniform level of quality, little or no loss of signals, and communication interruption is avoided. Circuit switching system employ permanent physical connection, applies only to each communication session. When a message is devised by a system, the same message is delivered through a single connected line or channel. Another is packet switching. In packet switching, message or communication data is broken up into small segments. Fixed length packet is created depending on the protocol and technologies employed, sent across the intermediate network to the destination. Each segment of data has its own header that contains source and destination information. The header is read by each intermediate system and is used to route each packet to its intended destination. Each channel or communication path is reserved for use only while a packet is being transmitted or packet is sent, the channel is made available for other communication parties. Packet switching doesn't enforce exclusivity or communication pathway. Packet switching can be seen as a logical transmission technology because addressing logic dictates how communication traverse intermediate network between communication party. Suppose a message contains numerous packets. These packets are delivered to a different pathway to destination system, and the destination system collect these packets and reassemble them. This is called packet switching. Packet switching and circuit switching have some differences. Circuit switching traffic is constant in circuit switching, while in packet switching it is bursty. And circuit switching is fixed known delay, while the packet switching contain variable delays in packet receiving and sending. Circuit switching connection oriented switching, while the packet switching is connectionless switching. After each packet, the connection is changed. Circuit switching is sensitive to connection loss. When connection is lost, the whole message is lost. While packet switching less sensitive to connection loss. Use primarily for voice communication circuit switching, and packet switching is used for all type of traffics. Encapsulation protocol. These protocols that encapsulate data is called encapsulation protocol. Point-to-point protocol we already discussed in previous lecture as an encapsulation protocol designed to transport or support transmission of IP traffic over a dial-up or point-to-point link, in which it includes its own header and tail to encapsulate the protocol data unit or datagram. It allows for multi-vendor interoperability of wide area network devices supporting serial link. All dial-up and most point-to-point communication or connections are serial in nature as opposed to parallel. Point-to-point protocol indicate or include a wide range of communication services, including assignment and management of IP addresses of the source and destination, management of synchronous communication, standardized encapsulation method, multiplexing, link configuration between two parties, link quality testing between any part of the networks, error detection during transmission, and feature of option negotiation such as compression as well. Miscellaneous security controls include transparency, characteristics of service, security control, and access mechanism that ensure that it is unseen by the user. When the normal user and end user are unaware of internal terminology or logical connections. Disable feature for security controls. The more transparent a security mechanism is, the less likely a user will be able to circumvent it or even be aware that it exists. Lack of direct evidence that a feature, service, or restriction exists and its impact on performance is minimal. The second is verifying integrity of data or information. Use a checksum called hash total performed on message or packet before it is sent to the destination over the communication pathway. Add to the header or end of the message, and it's called message digest. Once the message is received, the hash function is performed by the destination system, and the result is compared with the original hash received by the destination system. If the two hash total match, then there is high level of certainty that the message has not been altered or corrupted during transmission or pathway. Hash total are similar to cyclic redundancy check, and that they both act as an integrity tool for data. And another technique is record sequence checking. It verifies packet and message sequence integrity. Verify that no portion of message were lost and that all elements of message are in their proper order during the transmission and received at the endpoint. Transmission mechanism. Logging in a form of auditing focus on communication, record of particular abouts, source system, destination system, timestamp of communication, identification codes, transmission status, number of packets and the message which is delivered, size of the message on the transmission pathway, and so on. These pieces of information may be useful in troubleshooting problems occur during communication, and tracking down unauthorized communication are used against a system as a mean to extract data about how it functions. The next topic is email security. How emails are secure. by the systems during the transmission as well as storage. Email server using a simple mail transfer protocol SMTP to accept message from client, transport these messages to other servers and deposit messages into user or server based inbox there. Client retrieve a email from their server based inboxes using the post office protocol version 3 POP3 or internet message access protocol IMAP. All internet compatible email systems rely upon the X.400 standards for addressing and message handling. SMTP server imperative to properly configure authentication for both inbound and outbound email. Email security has some issues and challenges. Email is not secure. Many ways to add security to email, including these: provide for non-repudiation, restrict access to message to their intended recipient, maintain the integrity of message, authenticate and verify the source of message, verify the delivery of message, classify sensitive content within or attached to the message. Non-repudiation is a method of guaranteeing message transmission between parties via digital signature or and encryption. It is one of the 5 pillars of information assurance. The other 4 are availability, integrity, confidentiality, and authentication. Non-repudiation is often used for digital contracts, signatures, and email messages. Security policies have some issues. Acceptable use policy for email define what activity can and cannot be performed over an organization's email infrastructures. Access control lists over email should be maintained so that users have access to only their specific inbox and email archive database, at least from peer employee and unrestricted or unauthorized intruder. Privacy should be maintained. Mechanism and processes used to implement, maintain, and administer email for an organization should be clarified by the email management authorities. Backup and stored in archives for future use. User need to be made aware of this. If email is to be reviewed for violation by an intruder or by auditor within the management, user need to be informed of this act as well. Securing voice communication in information system is very important topic because most of the communication are done through voice communication. Voice communication occur over the IT infrastructure. It is important to implement mechanism to provide for authentication and integrity. Normal private branch exchange PBX are plain old telephone service ports. Voice communication are vulnerable to interception, eavesdropping, tapping, and other exploitation as well. Solution is that define acceptable use policy and train user on how to properly use the system of communication. Log and audit all activity on the exchange. Review the audit trials for security and use violation. Disable maintenance, modem and accounts. Change all defaults configurations, especially passwords and capabilities related to administrative and privilege features. Number of freakers tools are available on the market for voice communication usage. Black box are used to manipulate line voltage to steal long distance services. They are often just custom built circuit board with a battery and wire clip used for tapping the communication. Red box are used to simulate tone of coin being deposited into a pay phone. They are usually just small tape recorders. Black box are used to simulate 2600 Hz tone to interact directly with the telephone network trunk system backbone. This could be a vessel, a tape recorder, or a digital tone generator, as shown in the picture. White box are used to control the phone system. A white box is a dual tone multi-frequency generator keypad. It can be a custom built device or one of the pieces of equipment that most telephone repair personnel use for repairment and maintenance. So the management should be aware of these tools and their effects as well. Now next topic is the security boundaries. There are various security boundaries within the information system that must be secure for any violations. Line of intersection between any two areas, subnet, or environment that have different security requirement or needs within the system. Access between high security area and low security area, such as between LAN and internet. It is important to recognize the security boundary both on your network and the physical world as well. Division between security area can take many forms. For example, objects, the assets stored in the system may have difficult classification. Classification define what function can be performed by which user subject on which object assets. Distinction between classification as security boundary. Parameter between a protected area and unprotected one should always be clearly defined by the organization, by the management. Logically, security boundaries are the point where electronic communication interface with devices or services for which your organization is legally responsible. The area over which the organization is legally responsible determines the reach of the security policy in the physical realm. This can be the wall of an office, the wall of a building, or the fence around a campus. We call it physical realm. Thank you for today's lectures and for your listening. We have concluded now our part 2 of unit 4. Dear student, Allah Hafiz. You will have to study the further this lecture videos, provided the link and the slide. So be prepared your today lecture and today topics. That is for the next lecture. Allah Hafiz.